10.3, geometric sequence in series. So last time we talked about arithmetic sequence is where you add to get each term. Or like in this case, I'm adding 2 every single time. Now we're doing geometric sequence. That's where you multiply or divide to get each term. So it'll be like 2, 4, 8, 16, yada yada, right? In that case, I'm multiplying by 2 every single time. In this first case, I added 2 every single time. So that's a geometric sequence. Everything else works on the same way. As always, we need to know our formula. So this is if it's a geometric sequence, we can use this formula. A1 still means first term, just like before, right? AN's the nth term, right? N's a term number, right? Like right here, that would be A3 would be 8. It's third term. And then R is a little different. Now last time we said common difference, now we're doing a common ratio, you're multiplying. So R is a common ratio, but the way you find that is you do A2 over A1, second term over the first term. That's a 1, should have been a 1, there we go. Or if you want to do more generic, n plus 1 over n. So just to pick a term and put it over the one before it. Like here, 4 over 2 would be 2, or 8 over 4 is also 2. Right, so that's how you find R. Put A2 over A1. One term over the one before. And that's our general form for a geometric sequence. So just like before, let's write an equation given this stuff here, right? So as always, I will give you the formulas. You just gotta know how to use them. So this is the first one here, right? So there, right there is A1. This is what I need right there. Only thing else I need is R. Similar to the way you find R, A2 over A1. Now that's kind of tough. So that's one way you could say, you could use any term over the one before it. So in this case, I'm going to use this one over that one. So I'm going to do negative 16 over 2 and negative 8. So my R is negative 8. You're multiplying by negative 8 every single time. So my formula is going to be AN equals A1, which is negative 0.25, times R, which is negative 8, to the n minus 1. That's it. Now look at this one. A3 equals 16, R equals 4. I'm trying to find this sequence. You know what's missing? A1. Remember what I said last time. Anytime you're missing a term, you go back to the original formula. So we're going to use this formula to find our A1. So look what we have. Right, I have A3 equals 16. So that means when I plug in 3, I get 16. That's how that works, right? Plug in 3, you get 16. R is 4, so I have this. 16 equals A1 times 4 to the 3 minus 1. 16 equals A1 times, this is 2, so 4 squared is 16. Divide by 16, A1 equals 1. That's not the question. The question is what's the formula? So my formula is going to be A1 equals AN equals A1, which is 1, times R, which is 4, to the n minus 1. Right? So very similar to what we did last time, just now with multiplication instead. Here's another one, right? Same idea. So look at, notice I have A2 and I have R. I don't have A1, so let's write our formula down. A2, so A2 equals 96. So again, that means when I plug in 2, I get 96. So when I plug in 2, I get 96. R is negative 8, so this is all negative 8. So I get 96 equals A1 times negative 8 to the 2 minus 1. 96 equals A1. This is the same thing as this 1, so negative 8. Divide by negative 8. And I get A equals 12. Negative 12, actually. So my formula is going to be AN equals A1, which is just found, is negative 12, times R to the n minus 1. So there we go. Another way to do the problem, by the way, is if I know A2 is negative 96 and my R is negative 18, negative 8, if I want to find A3, you can just multiply by negative 8. And likewise, if you want to find A1, you can just divide by negative 8. And you get negative 12. Alright, so this is another way. If you're close to the numbers you need and you have the R, you just use the R to go up and down. How about geometric series? Well, geometric series is just like before, right? A series is when you add terms. Now, I don't have it here for some reason, but the formula for geometric series is this. Series of sum, Sn equals A1, 1 minus R to the n, all over 1 minus R. So that's the form for the geometric series. I have no idea why I don't have it on here. But so if you want to find the sum of first order terms, you use this formula. It's like this first one here. They want me to find the sum of the first 10 terms. And to notice how it says sum, so I'm using an S formula of the first 10 terms with R3 and A1, 2. So it's plugging in. Sum of the first 10 terms equals A1, which is 2, 1 minus 3 to the n power, all over 1 minus 3. And that you just plug into your calculator. So here we are, right? I'm going to put alpha y equals, this makes it easier for me, 2 times 1 minus 3 to the 10th power, all over 1 minus 3, which is negative 2. And I get 59,048. There you go. Right, this one, they're saying the nth term is 125. So notice how we're missing something? We don't have n. Right? I can't use this formula because I don't have n. So like I always say, if you're missing something, go back to the original formula. So in this case, we're going to go back to this formula. So an equals a1 to the r to the n minus 1. Plug everything in. So I know this is 125. This is 2000. This is r. This is 1 over 2, sorry. 1 half Tn minus 1. Now we got to solve a problem with an n in it, an exponential with the variable in it. That's logs. That's a log problem. So right, the idea you do this is you got to try to get it by itself. So divide by 2000. Ooh, I don't know what that is. So I use the calculator. So 125 divided by 2000. One more. 0.0625. Let me do that in fraction mode. Math, fraction. 1 over 16. Same difference. So I get that equals 1 half n minus 1. Now actually this is actually very interesting. I could take the natural log of both sides, bring the n down, divide it, blah blah blah. But I actually could make these match. They have the same base. This is the same thing as 1 over 2 to the 4th. So crest is inverted. I don't have to take the log of both sides. I can just solve the new tops here. 4 equals n minus 1. N equals 5. That's not the question though. The question is to find the sum. So now I gotta go back and still find the sum. I still use this formula. So a1. So now I went through all the work to figure out n is 5. I still have to do this, and a1 would be 2000. 1 minus 1 half to the 5th power, all over 1 minus 1 half. Put that into a calculator and get an answer. Now, just like I talked about before, if you want to find the sum this way, it's the same note as before, which just means like if I was doing this by hand, I'll plug in 4. So it'd be like 1/4, 3 to the 4 minus 1, plus, that's what the e means, plug in 5. So 1/4, 3 to the 5 minus 1, plus until you get to 12. Right, which will take forever. So another way we could do this is we could try to plug into the formula. So here's a couple things. The thing with the power is your r, and this is your a1. Notice how it matches the same formula? Actually, by that I mean the one up here, right? a1 r to the n minus 1. Only problem here is that we're not starting at 1. So I'd have to figure out my new a1 and stuff. Or you can use your calculator, right? Enter a calculator. If you go to math, you go down to sum, and you can type it in the way you see it. Right, same thing over here. Let's do this one actually. Let's see if I want to see what the answer is. So x equals 4 going to 12 1/4 times 3 to the x. Remember, we only ever use x. We don't have a k or anything fancy. Let's use x. And you get that. Around 66,000. Right? I can do the same thing here. Again, if I had started with the 1, then I could just use the formula, but this one makes it a little bit more annoying. I had to go from 2 to 9. It's the same concept. This next one. Find the first term of a series. So look what's going on here. Why don't you find A1 and they tell you the sum of the series is this, and is that in R3, right? Well, I have the sum, so let's use the sum formula. Now let's plug in what we have. We have the sum is negative 26,240. The first term is the thing I don't have. I do have R is -3 and N is 8. So I have this, negative 26,240 equals A1. 1 minus -3 to the 8, we gotta watch out there. And 1 minus -3. So what I mean by that, here this is 4, right? 2 negatives make a positive, I get 4. Here they don't. This goes first. You gotta figure out what -3 to the 8th is. So my calculator, because I don't know what that is, parentheses -3, very important, otherwise you can get it wrong, to the 8th power, right? If you just did this, your calculator assumes that the negative's on the outside, so it's gonna get you a negative answer, right? Odd power should get you positive. So this is 65261, but then 1 minus that gets me a negative 6560 all over 4. Multiply by 4, divide by that. So let's do that real quick in our calculator. Negative 26240. We're going to multiply by 4. And then we're going to divide by negative 6560. And 16. After all that work, wow. A1 equals 16. So that's how you use the geometric series, right? Same as before. If they're asking a series question, use the SN formula. If they ask you a term question, use the AN formula. If you're trying to find the sum of a series of this, you have 2 ways to do it. You can either use this formula by finding the A1 term, which means plug in the bottom number, and then figuring out your R, which is always this, and then plugging it in, or you can use your calculator. So that's it for sequence and series. But we're gonna add a bonus thing. Oh, actually, I forgot about the word problem. Heavy rain in Brienne's town caused the river to rise. The river rose 3 inches the first day, and each day after that rose twice as much. So it's like 3 inches the first day, rose twice as much, so 6, and 12, and 24. How much did the river rise in 5 days? So trying to say, I think they're asking how high is it on the 5th day, I think the question is. So we're going to find, that's a term number, let's find AN. So AN equals A1 times R to the N minus 1. Right, so how high is it on the 5th day? So the first term on the first day was 3. It doubles each day. 5 minus 1 equals what we're looking for. So this is a 4 power. 2 to the 4th is 16. Times 3 equals 48. So how much did it rise in 5 days? It rose 48 inches on the 5th day. We're going to skip this part because who cares? And then we're going to do this. So we're actually doing a lesson, but it's a short lesson. This is infinite geometric series. So the key thing behind this one we just did, if they say the word infinite. So what if I add forever to infinity? Well, we actually can't do it. If the number gets smaller, so let's say I get 12 and I divide it by 2, I get 6, then 3, then 1/2, then 1/4, and yada yada yada. If the number gets smaller like that, then you actually could find the infinite sum. If the number gets bigger, let's say I start at 6 and I double it every single time, then I can't. Right? So if it gets bigger, you can't do it because it keeps on getting too big. If it gets smaller, you can, because eventually you're just adding like small decimals, like practically 0. So how do I tell if it's getting bigger or smaller? Well, you tell it by the r. If r is greater than 1, if r is less than 1, then we call that it's getting smaller, and we call it converging. That means you can do it. If r is too big, if r is greater than 1, then it gets too big, and we call that divergent. So that's the general idea here. Now, what's the formula to find the sum? It's actually a super easy one. It's this one right here. So if you want to find the infinite sum, as with a little infinity sign, it would be a1 over 1 minus r. Super basic, right? Super basic formula. Key thing to keep in mind is actually if you can actually use it. And you can only use it if r is less than 1. Even though there's absolute value there, I don't care if it's negative or positive. It doesn't matter to me. I just care that it actually gets smaller in number size. So these first two, all I want to find is if I actually use the formula. Is it convergent or divergent, right? Is r less than 1 or is r bigger than 1? So remember the way we find r, we do a2 over a1. So negative 8 over 16. Again, negative 1/2. So that's less than 1, so that's convergent. I can't find the infinite sum. The next one, same idea. Negative 48 over 32. It's like negative 1 and I want to say 1/2-ish. The idea here is that it's bigger than 1. I know it's negative. I don't care, right? It's bigger than 1. This is divergent. So you cannot find it. Over here, next one. R is 0.7 over 0.5. So it's like 7 over 5. Or 1 2/5. Again, too big, so divergent. And then this one, so this one's tricky, right? It's going to be 1 over 1, which is 1. Is that convergent or divergent? The formula only works when it's less than 1, right? So less than 1 is divergent if it's 1 or bigger. So this one is divergent also. Example 2. Let's actually find the infinite sum of some of these things. So remember, first thing, make sure you can. So let's find r first, because we might not be able to. So here's a2, here's a1. So negative 2 over 4 is a negative 1/2. So it is convergent. I can find it. Now let's actually find it. So my formula is this right here. Infinite sum equals a1 over 1 minus r. So in this case, let's plug our stuff in. a1 is 4. 1 minus negative 1/2. Now you can do this on your calculator if you want, but come on. I'm going to get 3/2. That's the same thing as saying 4 divided by 3/2. Or 4 times reciprocal, which is 8 over 3. And we are done with that one. 2b, same idea. Let's find out first. R is 20 over 16. That is bigger than 1. Right, so this is divergent. You can't do it. And we're done with that one. Almost done, just a couple more. So this is the next one. Notice how it goes off into infinity. We want to find the infinite sum. Right, so I'll do the same thing. Find my r, make sure you can. 220 over 440. Zeros cancel out, I get 22 over 4. 4, which is 1/2. So that's my r, so I can, right? Use a formula. I get 440 over 1 minus 1/2. So it's 440 over 1/2. So 440 divided by 1/2, which means multiply by the reciprocal, which is 880. That's all it is, right? Let's say I went to this one also. This is the last one we're going to do. If I want to find the infinite sum of this, well, first, notice this is my r, and this is my a1. So if I'm doing my formula, how do I know what infinite sum? It says right there, an infinity sign. Over 1 minus r is my formula, right? I can make sure r is less than 1. Well, look at it. It's less than 1 already. So I can do this. It's convergent. And a1 is always a thing in front. So 12. Common denominator. I get 12 over 1/4. So it's 12 divided by 1/4. Which is 12 times 4. So 48. And that's how simple it is. Infinite sum is usually one of the easier things to do. Right? Only you got to make sure is that the r is less than 1. If it's bigger than 1, you can't do it. No solution. That's even easier. So that's all it is. And that's it.